Standard 1.9. Find the sine or cosine of an angle given its cosine or sine and quadrant. Let's take a look at what we're given here. We're given the cosine of an angle. We're given some information about theta, and our job is to find sine of theta. This given information, pi over 2 less than theta less than pi, is going to allow us to locate where our angle is being sketched. And pi over 2 is up here, pi is here, and so this information locates our angle in quadrant 2. So here's what our angle looks like. And let's just pick a point on the terminal ray, and let's drop down a triangle, a right triangle we're going to create here. Cosine of theta is negative 5 over 13. Cosine is x over r. And so in this sketch, the x value, or the horizontal portion of our triangle, has a length of 5. We're going to make it negative because it's located on the negative side of our graph. And r, which is the radius of our circle, or the hypotenuse of our triangle, is 13. Now we want to find sine of theta, which is y over r. We know r is 13, but we have to find y. So here's our point. Negative 5 is the x-coordinate. What's the y-coordinate? Well, we really have a right triangle here, and so we can set up negative 5 squared using Pythagorean theorem plus y squared equals 13 squared. We can simplify and solve for y. If you're familiar with the Pythagorean triple, you might not need to do this work. The triple is a 5, 12, 13 triangle. Y is 12. And it's positive because we're located up there in the second quadrant. And so sine of theta is y over r. The y-coordinate is 12. And r, as we said, is 13. Let's take a look at another example. Now we're given the sine and we're trying to find cosine. And our angle is located in, quadrant 4, between 270 and 360. So we're going to sketch our terminal ray here in quadrant 4. Okay. Here's our point. We know that sine is y over r, and so the y-coordinate for this point we can make negative 3. Makes sense, it's negative down here in the fourth quadrant. We know r is 8. Let's draw a triangle to the x-axis, and the length of the side of our triangle is 3. And we want to find, I did that wrong, sorry. The y value is 3. So it's 3 here. We can make it negative because we're going down. We're the negative portion of our graph. We want to find the x-coordinate here. So let's use Pythagorean theorem. X squared plus negative 3 squared equals 8 squared. X squared plus 9 equals 64. X squared equals 55. X equals root 55. So that's how long this side of our triangle is. And since we're in the fourth quadrant, x is positive, so the x-coordinate is positive root 55. And if we're trying to find the cosine of theta, cosine is defined as x over r. X is root 55, as we determined, and r is 8. This is standard 1.9, finding the sine or cosine of an angle given its cosine or sine and quadrant.